Let's go. Okay, let's get back to it. Welcome back, everyone. Welcome to yet one more stream of the Compiler Project. So, on Tuesday, I started the work of cleaning things before starting the next phase of the project, which will be the lowering into IR. Now that we have enough of the analysis. In doing so, on Tuesday, I did some work on the simplifier. Adding some tests and trying to see and finding actually a bug in it. But I did some work on the simplifier on Tuesday that I think this evening we're gonna revert. The idea of the simplifier is to remove unneeded complexity, but I made it to a point where we were actually performing optimizations. And I think that maybe this does not belong at this stage of the compiler and should instead be done in an optimization phase later on the AR. So I think I'm going to reduce the scope of the simplification phase and instead keep very non-controversial things in it that are like cannot error, things that are safe, and move some of the things we have done last time into the optimization phase later on. That means that we're gonna have to revert some of the tests we've added, which I think is fine. And yeah, that's basically what I have planned for this evening: is revert some of the changes we've made on Tuesday to the simplifier, add more tests, continue the cleanup, so that next week we can start tackling the lowering into AR. So yeah, it's gonna be not a very, unless I find something interesting, a new bug or something, this is gonna be a fairly chill stream this evening. Okay, so last time, if I go back to the simplifier, nope, I don't have it open. This is the simplification code, which does this thing here, where we do a basic AST rewrite when we stumble onto some specific combination of things. We replace them by something simpler. For instance, here we have adding something plus 0 is the same thing as just having the thing on the left. We don't need the plus 0, it is useless. So that kind of thing. What we've added last time is a mechanism for purity detection. For instance, here we have something multiplied by 0, and if the thing on the left cannot perform side effects, it is a constant or it is just a variable retrieval, then it can be removed without having an impact on the program, and therefore this whole thing can be replaced with a 0. However, here is where we end up with something that can be annoying. We could be replacing a division thing by a 0, which means we should probably handle a division by 0 as part of this compiler phase. And this is where I think I'm not comfortable with this design, and I think I want to change things. I think the simplification phase should not remove things even if we can detect that doing so is safe. This is pure thing, and trying to do this kind of optimization is, I think, should not be done as part of this simplification phase, but should be done as part of the optimization phase, and should be optional. It should be able to be disabled so that we can compare the behavior of with the optimization and without. So I think for this evening, I am going to remove all of the lines that contain an is pure, because I think those will be better served to be like in the optimization phase. This one I can keep. It doesn't check purity. Doing something and true is the and true is redundant. This, however, I will remove. So here I can probably just also. There we go. Looks a bit better. And I think that's about it in the sense of like now none of the things we have left use purity and do a rewrite that could introduce a change in behavior, like detecting a division by 0 at compile time, where without the optimization we would not see it. What I've been tempted to do as well, but I might not do that this evening, I think I want to give it more thought, is at the moment, we already do constant unfolding as part of the analysis process. For instance, if I do x equals 4 times 3 plus 2, this will be replaced by a x equals 14, basically. This 4 times 3 plus 2 will be calculated at compile time. We do this constant unfolding. However, if my expression is x times 3 times 4, I could replace it by x times 12, which is the same thing, but I don't do that. And because this is not simply a bunch of constants, I would need to do analysis on the shape of the expression. I think this is something that would belong in the simplifier, but I don't think this is something I want to do this evening, because this would be like some non-negligible amount of work for very small gains. And I think, again, this week is about cleaning what we have rather than introducing a bunch of new features, so that next week we can move on to the next phase of the compiler. So I think I am not going to tackle any of those things this evening, but I might do that in the future, perhaps when we have finished one iteration of the compiler. With that change, I need to change the tests. This would be in the integration tests for the simplification. And I have some arithmetic tests. This is a simplified code. I'm going to zoom this out a tiny bit, because otherwise, yeah, there we go. Source, there we go. So what I have here is a source file in our made-up language. Let me zoom it a bit. And this is the corresponding file post-simplification. This one should still be more or less the same, because here, none of the dangerous optimizations were done, so this test should still be the same. X plus 0 should be replaced by x minus 0 should be replaced by x, 0 plus x should be replaced by x, 0 minus x should be replaced by just minus x, times 1 to the power of 1 should all be replaced by x. We should have minus x here. Same thing with the 1 here. Let me check now for the other test. I think I had Boolean source and Boolean simplified. This is where it has made a change. Here I had one of those optimizations where I would short circuit, like on false and x, the Boolean operators are short circuiting. So if this is false, then there's no need to evaluate this. So at compile time, we can know this is false. However, in the case of x and false, we can only remove this evaluation of x if we know for sure that it would not perform side effects. It is a constant, or it is reading a variable which is already known and therefore cannot perform side effects. A function called there, however, could not be removed, because even if we know the result is going to be false, that function call still needs to be performed. Side effects still need to be performed. However, what we did last time, which again I have removed, was to say, well, we've done some purity analysis. We know that the thing on the left is pure, therefore we can remove it and replace that by return false. And I think, again, this will be part of the optimization phase, not the simplification phase. So here, no simplification will happen. This code will remain the same. Okay. Something else I've been thinking is something we've done last time as part of this purity analysis was to add annotation to expressions, like, is this expression pure? Can it perform side effects or not? We will probably want to extend this kind of analysis to have more annotations on the code. We will probably want to have a notion of purity for functions, and as in this function results is unused, can the function call be removed entirely? The answer is yes, if it is pure, which we will need to know. And I will probably also want to annotate expressions with a known value when there is a guarantee that the value will be, like, for instance, in this case, I cannot simplify x and false because I don't want to do this as part of this phase, but I still know that the result of this expression will always be false. So as something, I could already gather that as part of the analysis phase, put that in the annotation, and I could use that during the optimization phase. If there is an if that depends on this, for instance, I can know that it will never the if block will never execute, and I can just optimize it away. So there are things like this. I will probably want to add more annotations so that the optimizer phase has more to work with, but we're not there yet. So with those changes, hopefully the tests pass. Perfect. Now, something else I need to do this evening. I want to add more tests for actually the analysis phase. And I have not given a lot of thought about how I want to make those tests. So it's something we're going to improvise, I think, on stream. And something else I'm going to have to think about is how to persist the result of the analysis phase, because this is what will be used for incremental compilation. For incremental compilation, the result of analyzing a file before we lower into AR will be cached so that incremental compilation can be performed, which means it needs to be persisted in some kind of file format. And this is stuff I have not given a lot of thought about yet. So that's something we're going to need to think about. For now, I just want to make sure that there's enough coverage of those simplification things. I'm covering addition, subtraction, multiplication, division. I'm covering and or. I don't think I'm covering the negation, so I should add tests for this. And I guess equality with booleans is something I could also add the tests for. So let's go back to this. So here, minus x should be replaced by x and not x should be replaced by just x. And where did I want to test? I wanted to test x equals true. X equal false. Different from true and different from false. Okay. And the simplified version of this minus like not x should be x equal true should just be x equal false should be not x different from true should be not x, and x different from false should be x. Let's test that. And now we should be covering all of the simplifications that we do at the moment. Okay, that passes. Just to make sure I didn't break anything, if I go here and I do a not x here, this should break the test. Okay, the test is broken, perfect. Okay. Now the question is, how do we test the analysis phase? Because the entire API of the analysis phase is this. Given a bunch of context, the cache of all the definitions we have encountered in the process of the compilations, all the definitions from the dependencies both direct and indirect of the current module, the cache of all the symbols, a cache of all the function definitions for generic functions that need to be instantiated, for a list, for a map of everything that is exported by a given module that we have already processed, for a given module name, and for a past module. Give me a list of diagnostics, which is warning and errors, and maybe the resolved module, which will be this thing here. What identifiers are expected, what definitions have been analyzed, what generic functions need to have their source available for other modules to instantiate, and what symbols are exported, basically. How do we test this? I think there's different kind of tests we want to perform. Because I want to avoid as much as possible to tie my test to the implementation details. At the same time, at the moment, since I have extremely poor reporting, we don't have any error code, and a lot of things fail, I think what I need to do is basically I want to check most error cases, as in, do we handle this for most features of the language? So there's a lot of tests to write here, and ideally, I'll provide some kind of wrapper around the API of analyze module to guarantee, like, to make it so that I can test basic things like, oh, this errors with this error code, rather than testing the actual error. I think that's the way to go. Yeah, I think let's try that. That's going to be a lot of tests, I think. And that's fine. I think, yeah, this is. I'm just wondering if I just should do one big module, or if I should immediately start breaking it down based on the feature of the language that we want to test. Nah, I think for now, let's not make this too complicated. Let's do. Let's look at the simplification test. Okay. And we have the compile helper thing, which is there. Okay, so parsing, analyzing, simplifying, there we go. This is already not. There's a debate about how I want to structure my tests. Do I want to, because for now I don't have a lot of structure for like this passing of definitions and incremental compilation and so on, but I will probably want to test that as part of the test of the analysis, because that's a part of the compiler that I will need to write. But I don't want to duplicate that logic in the test, which means maybe everything related to, maybe most errors and stuff will be better served by end-to-end tests rather than me instrumenting the API of the analysis thing. I should instead have a bunch of golden tests where I try to compile this file and I get an OK, or I get an error message, and I just invoke the compiler, actually. If I do that, then that means I'm doing end-to-end tests rather than doing simple analysis of basic files. Which is easier in terms of test setup, but is less robust in the sense that, like, I will match like exact error messages, and a change in an error message will change the test. I don't think that's a bad thing. However, the downside is I don't yet have a compiler infrastructure for this. Currently, the main I'm using is very basic. It does the job, but you know, it's not great. So maybe what I should do, but I haven't planned this ahead of time, and I would like to start the streams with some amount of stuff planned. I could start making the actual thing for the compiler with compiler options and the different stages and all of that logic, which would probably include some kind of monadic structure to keep track of the incremental compilation that I can reuse and I can invoke from my tests. Unless I just go full end to end and my test actually invoke the compiler. But that means I can't write them yet because I don't have a compiler yet. Okay, this is something I might want to think about off stream so that I don't spend the stream just like thinking out loud and actually use the stream to do the thing. But I'm not sure yet how I want to do this. Okay. So to recap, things that I don't know yet that are blocking my progress on making tests here. I will need to structure how the compiler actually works, which is basically take this thing and make it proper, add compiler options, try to make this a proper reusable piece of code that I can use from my tests. That's one thing I need to think about off stream so that I know how to actually tackle it on stream. I need to figure out how to persist. That's something I could potentially start doing this evening, actually. The result of the analysis here, this resolved module, is something that will need to be persisted. That's not the equivalent of a .o file that contains, the symbols ready to be linked, but that's the equivalent of the HI information, I think, in Haskell, that contains all of the interface stuff that the compiler can then use to compile future modules. So that will need to be persisted somewhere. And that's a file format that I haven't decided yet. But since there is no documentation about it yet, I can start improvising things there and I can start thinking about how I want to do this and finding a way to persist it and restore it. It could be, for now, it could be a basically to JSON from JSON, and that would probably be enough to get us started. It will not be very efficient, but it doesn't have to be, right? So that's the second thing I will have to think about off stream. I need to prepare for the lowering into AR. There's a research paper I'm planning to use that describes the way to do this that I'm planning to reread before I do a stream about this for next week. And I think the other thing I want to do before I move on to that is documentation. And maybe this is where I should start this evening. Clean up documentation of the actual code, because a lot of the code is hard to read as it stands. A lot of it is poorly organized. Maybe since there's so many things that I want to plan off stream to actually be doing on stream, maybe what I should be doing this evening is actually just start writing more comments about the code. And start cleaning things that I have been postponing for a while. For instance, I could probably... The identifier is defined here as an equivalent to text, which is not very elegant. I don't think the tokens need a comment. What they are is pretty straightforward, I think. However, I think I'm going to create identifier.hs and move this here. Just going to break a bunch of things. I am tempted to make it a new type, actually. What's the upside of doing this? The upside of doing this would be that I cannot cast text to identifier, which means I cannot by mistake create an identifier that's not valid. Which means this can avoid the risk of ever creating an identifier that's not correct. The only downside then becomes that I cannot use string literals for identifier anywhere. Oh, but I could use a template Haskell thing so that the identifier is checked at compile time. And then I can create identifiers with just a string literal that is checked at compile time. That could be an idea. Okay. So that'd be something along those lines, with the idea of like the identifier is exported, but it is not, the constructor itself is not, so there's no way to construct an identifier from outside. It needs to use this make function. I should probably name this like so. Okay, so here this is the part where I will check the identifier for validity, which I suppose I can look at my lexer for this. And I guess I could also move some of the code of the lexer that check for the validity of an identifier to that particular file. Unless they're already, yes, I think they're already defined in this. And I think here what's going to change is I'm going to keep those functions, which are used by the lexer to decide how to like read a valid identifier. And I'm going to just make the predicate be part of the API of identifier. So let's copy this. How do I want to name this? Those functions are kind of, let's be very, yeah. This is very verbose, but this has the benefit of being very explicit. Okay, so now I can rewrite those to make use of identifier here. And this is now changed to be matching the predicate, and the predicate is not something that is required here. The predicate is valid first, valid. Oh, I don't have him. Is valid. There we go. And this becomes the predicate is gone. However, there's a bunch of places where we create identifiers that are no longer going to work. I think this is going to break a bunch of things, but this is the part of like, again, we're cleaning things at the moment. What I think would be interesting to do is, again, so this needs to be a maybe identifier. Does text have an uncons? I think it does, right? It does, perfect. So that would be first character remaining characters will be the result of doing an uncons on the text. I am gonna need import data text qualified as team. This gives me the first character and the remaining characters if they exist. If this is empty, that's an invalid identifier anyway, so that's fine. And I will guard that is valid first identifier thing, the first character. Guard that all is valid identifier character, the remaining characters. And if all of that has proven to be true, then I can return the new identifier, which is obtained by just giving the raw text to the constructor. We have validated that the text is correct. Now, it would be good to have a template Haskell function so that I can create identifiers from literals by running this piece of code at compile time. How did I do that for locate again? Because here, this list files function is defined as something that is template Haskell, and it is used if I look at the simplification tests, it is used like this. I probably that's probably the easiest way to go about this. I know I could use quasi quotes as well, but I don't remember how those work. Let's look at the Haskell wiki. I don't know how up to date this is. Let's actually look at the GHC documentation directly. There we go. Okay, so I can use something like this where I can use identifier or maybe just I in this notation. And it needs to be one of those. And a quasi-quarter is a thing that has a function for this thing appeared in an expression context, in a pattern context, in a type context, or a declaration context. It is, I think, fine for it to be. I think it is fine for it to be to just err in the cases we're not interested in. Interesting. It doesn't seem to be okay. So let's have a look at the definition of a quasi-quarter. Does this provide default things? Hmm. What instances does quasi-quarter have? None of them. Okay. I'm just confused by this example where they only give two of the functions and they don't give any for the others. Well, we can try this. So I will need this thing here. And I will define something named if I name it I, it's going to be conflicting with so many things in the code. That's going to be annoying. What would be a good name for a quasi-quarter that also maybe just ident? That's also going to be that's probably a combination of short enough and not used anywhere else in the code. Let's go. Let's do that. So this is going to be a quasi-quarter, which is going to be one of those. It's gonna be a quasi. And we're only gonna be interested in parsing an expression because we're only interested in creating identifiers in an expression context. Something like that. The identifier thing, quasi-quarter, will be exported. And this parse identifier function is going to be, according to the documentation, a function that takes a string and returns an expression in the context of template Haskell. Let's go back to locate to have a look. I do remember how to create expressions. They are complicated. I will th syntax. There, well, I probably want a more recent version if there is. Yeah, that's 7.6.3. That's very outdated. Okay, that's what I wanted. Perfect. And that's the... Okay, that's perfect. And I want... How do we create an expression? The expression I want to create will be something that calls the constructor. So that's going to be that. Well, except it's going to be applied the constructor to a value. So it's going to be an app E of a constructor E to an expression, which will be a value. We can figure out the value afterwards. This is going to be, in the context where this works, at the end, we will be outputting in our monadic queue thing an expression which will be an app E of the constructor to the value, and the constructor will be a con E, and the name will be identifier, and the value will be some kind of literal, which I guess will be a string literal. So wait, it needs to be a literal expression that is made of a string literal, which will be made of a string, which will be this raw string, and the conversion from string to text will happen thanks to the overloaded string language extension. Okay, so that should be the result if it is valid. Now, I don't remember how to indicate in this thing that something was wrong. Let's see the contents. Oh, actually, let's see if I do that in this file. I don't. But I guess this is just an IO monad. Error locations and IO. Report error. Okay, perfect. So here what I want to do is I want to check when I want to do a make identifier of the raw string, which I will convert into text. And if this fails, so on nothing, I want to report error, and the text of the error will be okay. And otherwise we continue here and we make the expression in the context an application of the identifier constructor to a string literal, that is this raw string. Okay, let's try to compile this first. This is going to break so many things. Ah, yes, I am using this syntax to get the name of this thing here, but that's not in scope. However, I need to check. I never remember in template Haskell which one is one and which one is two quotes. Names. Okay, double is type and single is value. So here I don't want the identifier type, I want the identifier constructor, so it's a single quote. Okay, but I still need to have template Haskell enabled in scope for this to work. Is alpha and is alphanum are things that come from data car here. Ah, yes, all operates on lists. Wait, no. No, it operates on a foldable. So is text is probably not foldable over characters because it is optimized and not just an array of characters. So text probably doesn't have foldable. Yep, it doesn't. But there might be an all defined in text. Yes, there is. So here I can do a text all instead. Not using the generic one for any foldable, but using the text specific function. Okay. This needs to be in a do block. Yeah, I think I don't want to do this on nothing. It is kind of ugly. Because what I want to do is basically do something only when this thing fails. Let's have a look at control monad extra, which I have as a dependency already. Do you have a when nothing? No, you don't. That being said, can I use the alternative there? Hmm. Yeah, I think I'm just gonna be I'm gonna be more explicit. I'm gonna do a case of this of if it's just something pass, and if it's nothing, I'll report the error. There we go. Wait, that is? Oh, okay. That makes me feel better. I was worried about like this the example in the documentation of the compiler of like not initializing the other fields, and was confused by that. And indeed, it is at the very least a warning. So I am going to So this is great. This requires pattern. Type. And quote declaration. And an incorrect quote is something that takes a string and returns a function from string to QA. It doesn't matter what it returns because all of them... that might be a problem. Report error returns a... gives me a unit, which is very annoying. Oh, but allow the current spice computation to carry on. To abort the computation, use fail. Okay, so this is what I want. I want to actually fail. Okay, so here incorrect quote, we'll just use that. So this is going to be the context. And this will be a function that ignores whatever is given as an argument and always fails with identifier cannot be used in context. Okay. No instance for show identifier. Yeah. Excuse me. Let's fix that. So now our identifier is missing a few things. It's missing at the very least show. The AST now needs to know about identifiers. And it needs at the very least EQ and probably, do I have any hash map based on identifier? It's probably worth putting on all of those immediately. Haha. Do I have an instance of pretty of text? No, so that means that whatever pretty thing I'm using had a definition for... It means this thing has an instance of pretty for text. They're all inconvenient. Okay, it does indeed. So that means I can, although it's a bit ugly, but that's fine, I can add this dependency here and add that identifiers can be prettified because text can be prettified in the first place. Okay. Tokens is unused in the AST. The AST doesn't need to know about the individual tokens. That is a better dependency. That's cleaner. Oh, hello and thank you. You're arriving for a very chill stream this evening. This week is about doing cleanups before moving on to the lowering into IR next week. There's a few things I need to plan for next week that I haven't planned, so this evening is just cleaning a few things that are not clean in the code, adding more documentation, adding more tests, that kind of thing. Just to have it as clean of a slate as possible before starting more difficult things next week. But yeah, thank you again for subscribing. That as always, you don't have to, and as always, I appreciate it. Here we depend on tokens for the names, but we probably don't need to anymore because we now have an identifier dedicated module and tokens are no longer required. Perfect. It's going to be the same thing here probably. Currently our diagnostic messages do not contain any tokens. Perfect. Huh, those do not... I suppose this is the problem. Because this is gonna attempt to make an identifier from so here I'm gonna introduce something. Which is gonna be slightly inelegant. Why is this pure with... Oh, because it is double, yes. In my parsing monad, with all of those functions here, how did I call it? Alex, make identifier? Yeah, perfect. Text identifier. And this is gonna be given some raw text, make identifier of the raw text. And from maybe, so I can just remove the argument. And from maybe, and here, this is gonna be, again, I will need at some point to have better error handling. This is gonna be an internal compiler error, because if the parser works correctly, if those functions work correctly, this make identifier can never fail. And as a result, can never return a nothing. If it happens, that's an internal compiler error. There we go. Okay. Alex doesn't know about... Which is because here I import tokens, but now I also need to import identifier, which I will sort manually, because this is not recognized as a Haskell file, so it doesn't do any formatting. Okay. Ambiguous. That's in the Lexa. Okay. Oh, do I have something called make identifier here as well? I do. I guess I can hide this one here. Hello, yes, this is a compiler for... So the idea of this project is I'm compiling a made-up language into an esoteric language. So this is not like a real-world use case of a real practical language, but the goal is less about it being practical and more about it being both a like very like long project in Haskell to showcase the strengths of Haskell and also to showcase how a compiler would work with a slightly simpler use case. So what I'm compiling is a language that looks like Rust and is a subset of Rust with no memory allocation, no lifetimes, like, sorry, no dynamic allocation, no lifetime. So very simple subset of Rust. And we compile into an esoteric language. Specifically, we compile into Piètre, which is an esoteric language in which the source code is an image. So this is the first program we have generated with the backend of the compiler. It prints 2 characters and it exits, but this is a valid Piètre program. And the goal is to take something that looks like Rust and compiles it to an image like this. We already have the parser and the analysis, so type checking, name checking, and we already have all of the backend, as in given some bytecode, generate an image. So now what we're missing is all of the things in the middle. This week I'm doing some cleanups, and next week I'm starting the lowering into AR. So that's the project. And here I'm making some changes since, again, just before going on vacation, I finished the analysis phase. This evening, I'm doing a bunch of cleanups, making the code more readable, removing old, dirty things. The whole compiler, well, I guess you could, without dynamic memory allocation, it's going to be a bit restrictive, but theoretically, you could write a compiler in that made-up language, which would then become an image. I would be surprised if no one had made like I'm 95% certain there is a brainfuck interpreter written in Piètre, so a brainfuck interpreter which is itself an image. I think that exists. Piètre is a very fun language. But yeah, that's the project. And here, so this evening, I am doing some cleanups. I've made identifier into a new dedicated type rather than just being a raw string, and this breaks so many things that I'm fixing everything I have broken, and then I'm going to add some tests for it. My not so secret goal is to try to have the compiler finished before December, because I'd like to be able to use my made-up language to do the advent of code in Piètre by generating Piètre solutions from our Rust-like language. But I don't think it will be good enough by December. We'll see. It depends on how much progress we make in the upcoming weeks. Kim? No instance for is string. Yes. Okay. So this is where we are going to want to use our quasi-quota. Do I have quasi-quotes enabled as part of my options? I don't. Okay. So I'm going to need... Do I want to enable them by default? Probably not. Is it quasi-quotes? I had the documentation open earlier. Quasi-quotes with an S, I think it is. Yep. Perfect. So now all of those I should be able to replace with this syntax. I immediately see a problem, however. The idea of this syntax is, if it works, the syntax highlighter seems to be very unhappy about it. Wait, it's not the proper syntax. This is the proper syntax. There we go. Is that this will create an identifier at compile time by running this function right there that validates that it is a valid identifier at runtime at compile time, so that I do not have a constructor exposed to the rest of the code that allows to create an identifier from any raw string. The problem is, here I want to use an identifier. Maybe it just means I'm wrong about this. Maybe it's fine for an identifier to not be. Maybe it's fine for an identifier to not be valid as far as the language is concerned, but to be constructed as such, as long as the parser does not accept them as such. So maybe I'm going to revert all of this. Hello. Two questions at the same time. So long time no see. Yes, sorry, I took a long break over the summer. Some of it was planned. I had some vacation. Some of it was not planned. I was sick after coming back. And some of it was not planned. After I recovered, Silk Song came out and I lost a week to that game. So it was a longer break than intended. And for getting deeper into Haskell, it really depends on what you like. There's no better answer than like practice, right? Like doing things with the language to get more familiar with it. For that, different people have different preferences. Some people like to contribute to open source projects because you already have a project that has a significant size that you can look into and see how it's architectured, how the code exists. You don't have to make everything from scratch. You can try to make changes to something that's already there. Some people prefer smaller exercises to try to think about some things in isolation. And if you prefer that second thing of a small project in isolation, my two recommendations would be the advent of code. That's the thing I usually stream every December because it's fun. It's very simple problems that go from very easy to a lot more difficult, and allow you to have very basic problems with well-known solutions that you can compare with. And there are sites like Exorcism to try to have small things in isolation as well. I'm not completely neutral there. I used to be a mentor on the Haskell track for Exorcism, so I'm slightly biased there. But yeah, it's if you prefer big projects, my biggest recommendation would be contributing to open source. If you prefer small things in isolation, Exorcism, Advent of Code would be, I think, good places to get started with the language, basically. And for both of those, you will have the ability to look up existing solutions, compare with what people do. You're not just doing things on your own without for Advent of Code, you can look at all of the repos on GitHub for people who do it in Haskell to compare your approach to other people. And if you do something like Exorcism, then you will have a mentor look at your code and tell you, well, this is nice, but this is more idiomatic, or nice find, this library is pretty good for this, that kind of thing. I hope this helps. So here I'm going to revert this change. I think it was not a good change. I am going to therefore remove this. The quasi-quotes go away, and I go back here, and the quasi-quoter goes away. And as a result, I think I can export everything out of this file. There's no longer a need. Yeah, okay. Yeah, Advent of Code is, I think, a very good resource for this. Bigger projects, I am not sure which ones I would recommend. some people would say start with GHC basically, but I think GHC is daunting. It's an old project, it's a big project, it has a lot of protocol around it. I've made some very minor contributions to GHC and it was very difficult to get started. So finding a good open source project for large scale, like for like getting contributions out, maybe Pandoc? But I don't have a good recommendation, I guess. And I think here I'm just gonna make it is string, basically. I'm starting to question whether I actually want to have it as a new type. I don't think it's a bad idea, but I still think I want to have this just because I want to isolate it from the tokens. It should be separate. Most of the code cares about identifiers but doesn't care about tokens, so that it is a clean separation that's, I think, good. But maybe I can remove all of this since it's fine for the code to create invalid identifiers. It's just the user's code that cannot. And that means I can probably also revert the changes that I have made in the Alex stuff. Yeah, all of this goes away. Which means if I go to here, what have I changed in here? This remains, so this import will have to remain, so I remove it from the diff. Those changes remain, but those changes have to be removed. I think this entire chunk needs to be removed. Okay, so we don't keep any of this. And the good news is that yes, okay, I'm just going to do it manually. I can import identifier and I can go to make identifier. And here, this is just going to be making an identifier from text. There we go. Which is easier. Here, what changes? Nothing here. Okay, so that should be all. We should be back to something that works. This makes this file a bit useless. Unless, I suppose, I move more identifier-related code to this file. I don't know. But I still think it's cleaner to have code that requires knowing the identifiers, not import tokens, because that feels inelegant for sure. Okay. Tokens no longer required here. That's a good change. And here, this imports tokens and should import identifier instead. Okay. I'm 90% certain I can remove tokens from this because this is the analysis and the analysis does not care about tokens. There we go. And this is going to be the same thing here. Here, this requires wrapping it in an identifier constructor. But that's part of the test, which is good. Which means everything else compiles. And this, yes, I started adding this file and I didn't do anything with it. I'm just actually gonna remove it entirely because I've decided to not work on that this evening. So test, where are you? Untracked file probably. This one can go away. And yet this year I'm going to do the same thing, I think. I will probably interrupt some of those streams to do the Advent of Code in Haskell when it comes out. I might do the thing. Usually, what I do is I try to stream on every weekday for the Advent of Code, which is a bit more of an intense schedule than what I've been doing for this project. What I might do is, as a result, do Monday, Wednesday, Friday, do the Advent of Code, and keep Tuesday, Thursday for this project to avoid making it like putting the project on hold for all of December. We'll see. Yes, of course. And here I will need to wrap that in an identifier. Okay. And this requires, I don't know if tokens are required for this file. We will see that in a second. No instance for arbitrary text. Huh. Oh, of course, yeah. Of course, I was defining an instance of arbitrary on the identifier. But identifier was just text. So this instance is actually probably the one I want for text. Actually, no. This instance is a lot better on identifier because it gives me something that is a valid identifier within the code, but I probably need a separate identifier for text, which is going to be used for string literals, which for now are not wrapped in a dedicated type. And I guess arbitrary text. There's no. I guess arbitrary text will be just arbitrary string, basically. So I guess pack arbitrary and shrink will be a map the pack of map of shrink of unpack. Make that a string, use the shrink function of strings and pack it back. Okay, and tokens no longer needed. There we go. I don't think this will reveal new broken things just because since we don't support string literals yet, I think beyond parsing. This is okay, so that's this is a non-empty list of identifier. Okay. And so this is so here I will need to map that to the raw underlying text, which I think is just called raw identifier, which will need to be imported from here, which is not in scope. Okay, so module name is currently, yeah, so I need to wrap that as an identifier. Wait, why is the module name an identifier? I guess that makes sense. Since the code passes an import path or a use path with identifiers, then a module name must be a valid identifier. I guess that makes sense. And therefore is subject to the same constraints. I suppose it's a name that I have. Module name is non-empty identifier. Yeah, okay. Okay, so this change passes and the tests still pass. That's good. Because what I wanted to do this evening was to look at something like parsing and start adding documentation to those things. One concern I have at the moment with the project as it stands is that someone who has been watching every single stream and knows a bit of Haskell can probably know what each thing in the code does. But for someone who's not familiar with the project, I think it has grown in complexity and in lack of documentation to a point where it's starting to be hard to read. And my goal with like the stages and the representations like folders was to have a very clear thing of this, like this is approachable for someone who doesn't know how the code base is structured. Like stages, I should remove the generation of the HIE files, it's useless. But like there is a parsing, there is a simplification, there is an analysis, like, and you can just look at this and get the API in the sense of each phase. But that's not very clear yet, I think. So I think this should probably be documented. And something else that I think I will want to do, but I don't know if I'm gonna do that this evening, but I might, is start working on my overall compiler structure. At the moment, each phase is just a pure function that returns either some kind of error or its result. So here the lexer will result either a parse error or a list of tokens with location, basically. And likewise, my analysis phase will return. That takes a bunch of things which are required for incremental compilation and returns a list of diagnostics and maybe a resolve module. I think what I will want to do is start having some kind of compiler monad that one keeps track of errors and is able to abort a given phase after if a phase results in things that cannot be recovered from, and keeps track of that kind of stuff, like what have we compiled so far, what is our context, how can we perform incremental compilation, and then make every such function, every stage function, be something that operates within the monad and doesn't take that many different things, which will make error handling and dealing with the context a lot easier. Unless I keep those functions all very simple, pure functions like this, and I do a bridge to them in my compiler monad. That's also an option. Actually, do I want to keep this lex file, this lex function? I think it's only used. I don't think it's used anywhere. I don't think it's used anywhere. And it exports, like it shows a lot of, yeah, maybe I'm just gonna remove this function actually. I was too aggressive in my removing of imports. There we go. Yeah, okay. That function, that's an easier way of documenting the function. Let's remove it altogether. But I think, yeah, starting to write documentation for some of the things might be a good idea. So for parsing, I know monad has some description. Okay. Is there anything else in this folder that I want? No. I have a parsing. Deserves some documentation as well. Is that the syntax I have used? Yes. It's something I've been wondering before going on vacation, actually, is writing documentation as part of the stream is, I think, good in the sense of like this showcase. Like, my goal with this project was to never write any code off stream. I so that the entire project is documented, the entire project is on YouTube afterwards. But that also means writing documentation on stream because I think it's part of the effort, it's part of the work. And but at the same time, I worry that maybe a stream of me writing documentation is not the most interesting thing, and I don't know if I should do like I should schedule smaller streams outside of the regular schedule to do some of the like camera off, just writing documentation kind of thing. So it's part of the thing on camera, it's part of the archive, but maybe not the main streams where people maybe expect actual interesting code rather than just documentation. I don't know. I'm not sure what the best approach here is. Actually, do I define what a parse error is? Parse error. It's just a string for now. Okay. At some point, we'll definitely need to do a stream on like actually improving our errors. That might be something I do this evening. Actually, I could start. I could start doing some of the internal error handling a bit better. Uh, I wonder if this would work if rendered on GitHub. Probably not. I'll have to check actually to make this work. I can probably make this work as Haddock documentation. Yeah, I think this documentation is useless. Parse module, parse expression are clear enough on their own. Like I feel this is the kind of documentation that doesn't add any value to this. Yeah, I think this is fine. Having if the Lex function was still there, I think it would have needed documentation. I think this is good enough as far as parsing goes. And if I look at parsing monad, like, is this file clear enough for someone who has never seen the project before? If they try to read this, do I want to add more to this? The parser monad is explained already in this comment. Yeah, this needs to really be changed. I guess, however, those could be documented. Okay. The only thing is I might at some point change from happy to megaparsec, and maybe I shouldn't invest too much time in documenting happy if I end up changing it. Okay. This would be a good. Yes, I'm going. And I think, okay, adding documentation for this function is a good place because I don't think I mentioned it here. Yeah, I don't mention it here. Um, well, it's not. Well, it's not the content part of our compiler. So Alex and Happy are the Haskell equivalent of what other languages call Bison and Yak, I think, are the C++ one. So like lexer generator and parser generator, basically. And for why Alex, I suppose it's because it's the lexer. So Lex and Alex. That's probably actually we can check. Alex is a tool for generating lexical analyzers in Haskell. Is there somewhere a Lex and Flex are the names of the existing one for C++. So Bison must be an equivalent to Yak, I suppose, then. But why the name Alex? That doesn't seem to be documented. Yep, so... Oh, sorry, no, it's not my own thing. I'm using it because, again, since I want to take this project, even though the compiler is for a made up language targeting an esoteric language, I want this to be as serious as a compiler project as I can. So I am using Alex and Happy at the moment because those are the things that are used in GHC to compile Haskell. So those are very standard tools for compiler to write compilers, which is why I'm using them. Uh, in using them, I have encountered a bunch of issues. The one I'm writing about here, where Alex uses bytes and not Unicode code points, being one of them. I even found a bug in, was it Alex or Happy? I think it was a bug in Alex. It was a bug that had been there for 7 years that I found writing this project. And I, as much as with Alex, I have found enough workarounds that it works for my purposes now. I think at some point I will replace Happy with Megaparsec and write my own recursive descent parser rather than using a parser generator like I'm doing at the moment. But that will be a side project for later. This works well enough for now. Okay. I think this is the most important function to document because that is the one that is assumed by Alex to exist. I don't know if input previous character is used. I don't think it is because I don't think I have any look back, like any conditional thing. How is it called in Alex actually? Oh, wrong. There we go. Yeah, I think this is required for the context interface to an Alex generated Lexa. And if I look for Alex input, there we go. Yes, this is for left contexts. Okay. Alex error is, I think, likewise, and it might be the last. I think Alex error is the last one of the functions that Alex expects. Actually, no. I think the fact that it has a different type means no. This is not something that is part of Alex. I've just named my function Alex for things that require for that Alex uses. I think this one doesn't require really a comment because Alex expect has a character returns a parser that does nothing, which unless try expected Alex error, that feels pretty straightforward. This one, however, is a bit more complex. I'm gonna document it as well. That's actually a combinator. Actually, I can document this as well. Okay. Okay. I'm gonna move this function alongside try and expect where it belongs, I think. I don't think there's any template Haskell in this file, so it's gonna be fine to reorder the functions. There we go. Okay. So we have try, which tries to pass one given character. We have get matching character. Actually, why did I not name this one Alex something? Huh. Yeah, I'm not gonna change it now. Expect, which takes a character and will just fail pass error if it's not found. We have those for particular things like string literals and identifiers. And yeah, there's no need to do that. Okay. Now, do I want to rename get matching character? Is it used anywhere? Rather, is it used within the lexer? It is. It is used within the lexer. It would probably make more sense then to keep the same logic of calling it Alex something. So try is for a given character. So try predicate. Try if. There we go. And now I can find all instances of get matching. There we go. And replace them with Alex try if. Do I have... I have here a try if const true. That's just a get next character. What's the point of doing this? No, that's not true. It's not the same thing as get next character. I suppose this can still fail if we are at the end of file. So this is get anything as long... But I could probably... rename that Alex any. It's just only one, so I think it's fine. Okay. Here, there's one place. No, it's used in two places. Okay. So I'm actually going to introduce, I have try if, expect. I'm going to make an any. Which is going to be a parser for a maybe character. And I guess it should be called try any, because I want to indicate with the try ones that they don't, using the try naming convention to indicate that they don't change the state on failing to pass something. Okay. So this is going to be also a parser of a maybe thing, and that's basically... Aha. I have something that's inconsistent here. This one will, on the end of stream, will return false. But this one on an end of stream will return an error. Okay, so here I'm using it for reading a string literal. Wait, does that mean I think this is incorrect. I think I found a bug by doing this documentation thing. I think if we try to scan a file that contains a string literal and does not end, like ends with nothing, we'll be fine? Which is weird. We should not be fine. Maybe I've removed the lex function earlier because it's not needed for the interface to that module, but maybe for the purpose of testing, I might want to keep it. Okay, so let's go back and let's go back here. And I'm gonna put this back. I think. Oh, hello everyone. I'm gonna put this back. I think I'm gonna actually want to write some unit tests for this because I think I found a bug while writing documentation. Hello, welcome everyone. This is a somewhat chill stream. I finished one big step just before going on vacation, so I'm doing a cleanup stream of writing documentation, adding tests, trying to make sure that everything is in a good state before starting the next phase of the compiler, probably next week. So I'm probably gonna want to provide. That is very unlikely, but not technically impossible. I have two videos on YouTube, one of them being the announcement for this project. I want to do more, but I haven't. It's difficult to find the time because doing YouTube stuff takes a really long time. I've made one video 2 years ago already at this point, I think, about the problem with monads. About why monad is such a pain point in Haskell and everything. And I have made a small video as well for to introduce this project, what this project is about and everything. But I'm gonna be honest, the sentence I recognize you from YouTube is both flattering and terrifying. But yeah, I'm here. I was writing documentation for the inner functions of the parsing and lexing phase, and in doing so, I found something that seems inconsistent, and I think I found a bug in my lexer. So I am reintroducing this. Oh God, good question. Some of those I've had for at this point 3 decades. So it's hard to say which one is my favorite. I have a soft spot for the Discworld series. I think there's almost all of them in there. There is some organization to this madness, but from this angle, it might be hard to see. The Discworld series from Terry Pratchett. If you're not familiar with it, good news, you have an entire series of books to discover. They're all fantastic. So I wanted to quickly. It's fantasy technically, but Pratchett was a master at writing about real world issues using fantasies as a pretext for them. They are all they're mostly independent of one another. You will find easily on Reddit like uh, reading order recommendations because you don't have to actually read them in publishing order. And I'm sure there are some entire Reddit threads of like where to start with that series, but there's like I haven't read much from her, and I have some. There is somewhere behind all of this a pile of books that I need to read. There is some of hers in there, and I haven't read much from her, and I want to read more from her. Okay, so I think yeah, I've heard only good stuff, and I need to get to her at some point. I'm gonna keep those functions as is for now. I think what I want to do is I want to make this compile after the changes I've made, and I want to test my hypothesis that my Alex try function is broken. Yes, that doesn't make sense. Try any is actually this should be pure nothing. Or should it be an Alex error? I think it should be an Alex error. We should never end up with I think that's the problem I have with my Alex try. And otherwise, if I have any here, the predicate will always be assumed to be true. So if I have a byte, no matter what it is, I always do that, which is to update the current state, which is our previous state where I update the parser location, the parser input, the previous character, and I return the character. Okay. Ah, I'm just gonna name it C like I have everywhere else. Wait, why am I doing here this Alex try is using the Alex get byte, but this one is doing okay. Since here I'm doing a predicate on character, I think it's fine to get an entire character out of the input stream, while this one is used to check. Hmm. No, I think this one should also use this instead. I think it's inconsistent, and I think the fact that it's inconsistent is part of the problem. Okay, so let's rewrite Alex try. Actually, I'm going to leave it as is for now, just because I want to prove what I think, which is that there is a bug in this. Okay. So I just need to make this compile. Hopefully none of the tests have changed since last time. Okay. So now what I want to try is, let's do a stack GHCI. And I want to try to call this lex function, and I want to test something, which is, I believe, interactive, it doesn't matter. I believe that if I could have something like, I don't know, const foo equals and a string literal that is not finished, I think this will successfully lex, which it shouldn't. It doesn't. Okay. Okay, so this scans okay, and it scans as being the keyword const, and then an identifier foo, and then an operator assign, and then a literal int. Okay, so I was wrong about this not working. So the question is, why does it work then? Because if I look at the lexer here, oh, is it because no. So it's not something I do here. Oh, it might be in the Alex get next token, except that's a generated function from me. It's not one I've actually written, I think. Unless it is in here. It is here. Okay. Okay. And when I match a opening quote, I try to lex a string literal, which I do with a read string characters, which is this, excuse me, this. I suppose this works by accident. Because whenever this encounters, okay. So this would tell me that I failed to pass. So with the current bug in Alex try, this would tell me that like, oh, trying to pass a double quote failed, which this function would interpret as like, oh, we are still in a string literal, but, and then it would therefore call this one, which is here, which would fail if we don't get the next character. Yeah, on nothing. So this can be removed entirely. Okay. So this can be cleaned, I think. Let's go back here and let's rewrite that documentation. So Alex try. I'm gonna make an Alex try any first. No, it's fine. So Alex takes a character and tries to pass and returns a boolean. Did we successfully pass that character or no? However, if we are, this means we are trying to pass a character, which means if we find the end of stream, that's an error. For now, I don't have proper, like, good errors for this. Maybe at some point I will forward some kind of error message for why this would be a problem to encounter the. I guess this could be something like found end of stream, expecting this one, basically. Okay. And at this point, I think I could, since I'm dealing with individual characters, I could replace it to use this instead, as in not use the byte logic. Which means all of those functions are now the same, basically. Which means I should probably introduce an internal function that does update the state. Because all three functions do the exact same thing. So maybe... Yeah, I'm going to introduce, I think, a small helper function below this, which is going to be called update state with, and which is going to take a character text and return a parser thing. Which is going to take the character we have successfully scanned. That's our match. That's our remaining input. And we are going to do a modify of the state. We update the state. And what we do is we are going to apply a function to that. And that function that we apply is those three things. Update the parser location with... Oh, this is assuming that I have access. Okay, so let's not do it that way. So I'm calling the modify function that will apply the given function on the underlying state. Oh, hello, I hadn't seen you arriving, sorry. And what we're gonna do is I'm just gonna copy this. We're gonna return the new state after the change, which is gonna be this. And with those 3 modifications applied, where we've updated location, we update what's remaining of the parser input, and we said that the previous character was this match. And now that means that all of those functions can be rewritten as and I'm almost tempted to do a thing where I'm taking those as a pair as an argument, because I will be getting them as a pair anyway. And what actually no, because I need to check the predicate. Okay, so no, I'm not going to do that. So I'm gonna keep it very explicit as a result. Let's do that. This is gonna be C and remaining match and remaining will be the result of doing this uncons on the parser input on nothing Alex error. And here, all of this is now replaced by update state with match and remaining. Instruction sets. Do you mean as like what's our starting language, or what do you mean exactly? Like what architecture I'm targeting? And here then we can just return the just match. And if you mean if you mean the architecture we're targeting, well, here is the instruction set that we're going to support. Push of an int, push of an address, pop the stack, add, subtract, multiply, divide, mod, not, greater, duplicate, roll. Input of an int, input of a character, output of an int, output of a character. Entrance is an internal thing that's not going to be part of the output. And so our branch, return, terminate. And if you're wondering, what is this instruction set? What's this? Those are the basic instructions of a esoteric language called Piètre, in which the source code is an image, and the color transitions within the image dictate which instruction is executed. And those are the basic things, the basic instructions of the thing. So for instance, this program has been generated by the backend of our compiler, and it performs like it prints a character and it stops. It performs nothing interesting, but it is composed of basic instructions of this instruction set from the bytecode that I was showing you, because the goal of this is to compile to stack-based languages. So languages that have basically a push, a pop, a roll, and that kind of things. Piètre is the one I'm targeting, but once we have the entire compiler architecture, we can probably target other stack-based languages. I don't know how that would work, but it might not be impossible to make a backend that would output some some Forth, for instance, because Forth is a stack-based language as well. We could also target whitespace, because if I remember correctly, whitespace is also stack-based. Like any stack-based language that has this kind of instructions, we could target that. Ace as a side project for this compiler is another thing I want to do, which is starting probably next week, we're going to be working on the IR, the intermediary representation, how we're going to encode the instructions before doing the code generation to the bytecode. And I will base the IR for this project on the LLVMIR. It's going to be a much, much, much simpler version of the LLVMIR, but my goal is to have something that's a bit similar to it. A side project I have will be to then do a conversion that like takes our IR and converts it into the LLVMIR, so that we can then compile the use LLVM as the backend and compile the input code into whatever architecture we want and compile it into an actual binary, and then we can compare how the Piètre thing works with the bytecode and the generation into an image compared to actually using the real LLVM to generate an actual binary and check that the binaries actually match, which is a test I'm planning to write at some point. But that's a side project when everything works. So yeah, that's the goal. So here, going back to this cleaning thing, now I have this update state with, and now I can rewrite this like this. Here, I still have to do something, which is if predicate match, then we do that. Else pure nothing. And Alex try, which is here, is gonna become the same thing, except if match is expected, then update state and pure true. It's a bit, I guess. Okay. When correct, update state with, and then return the boolean that indicates whether it's correct. That avoids doing an if, return true, else return false, which I think is ugly. Okay. So now we've made this a lot more consistent across those different functions. The names are more consistent, the behavior yes, and therefore I'm not gonna rewrite this here. And the internal state is updated. Okay. And now this one becomes Alex any. It's not a try function. It doesn't, because on air it will give me an, like, if I don't manage to find a character, it will give me an error, and therefore I can just return the match every single time. Okay. Now I will want to check every use of Alex try. Try expected, that's correct. Now I have this Alex try if const true on nothing Alex error. So like try to pass the next character. If it passes the predicate true, and on nothing, which means the only way this was possible was end of file, raise an error, this makes no sense. This whole thing can go away, and get next car becomes Alex any. And I guess I could probably introduce, I have try that will, I have expect. If we fail to find the given character, I suppose I could introduce expect if that takes a predicate and returns a parser for that character. And that becomes an Alex try if of the predicate. On nothing M Alex air. Which I think is something I had here underneath. Yep, that's exactly what I had. This is therefore a Alex expect if. This is an Alex try if. Okay. That is a lot more consistent. And I forgot the expect if here. Okay. So not only do we have a consistent behavior across those different functions, they now have a consistent naming scheme, which is a lot better than where we were half an hour ago. I'm gonna put any first, I think. There we go. Scan any character. Okay. Now, let's see all of the tries that I had. Extra expected, that's fine. Okay. I have no longer any const true and remains. That's good. Now let's go back to the Lexer and let's see all of the Alex functions I'm calling. So here the Alex try here will fail for, okay, so that should be fine still. Yeah. Void Alex try if const true. That's not great. Ah, this is a double look ahead. Okay. So actually what I want, I suppose, is just an Alex any here. As in move one character from the stream. Until we are able to find the end of the comment. Okay. Do I have any other weird use of try? Nope. Okay. So now this should be a lot. This is a lot cleaner now. Of course, when it works. Update state with match and remaining. This should be. Oh yes, of course. I have made them back into a proper function rather than taking a tuple. Okay. This doesn't take expected, it takes a predicate. Current isn't used, perfect. Current isn't used, perfect. I can actually probably simplify this since I only care about the parser input and there is a lens and I am in a state monad. I can do a uses parser input and the function I apply is uncons t uncons. And on nothing m, let me just check that it is indeed uses like this, which would be in control lens getter. Uses, there we go, lens like function. Yep, that's correct. So it uses the parser input and I apply the function uncons. And if it's this gives me a monadic nothing, I return an Alex error. Otherwise, I get this, which I decompose here and then update perfect. Okay, so I can do the same thing here, which is a tiny bit more concise. Okay, so now that compiles. Perfect. Let's see what breaks based on that. Nothing. The tests pass. Okay. So now, not only do we have something that's a lot cleaner, like the name of the functions are more consistent, we have documentation for most of them, and yeah, that's better. So I think, yeah, parsing at this point should be accessible to someone who's familiar with Haskell but doesn't know anything about the project. With this entry point with those three functions, and then all of the internal stuff here properly commented. Okay. Another thing, an unrelated thing I wanted to do, and I should probably at some point, actually, I'm going to do that now. I should commit most of this. I should have actually committed when I made the change to identifier, just because it makes so many changes everywhere. So it has one commit. I'm not too strict about commit etiquette for now, since we are not yet at the point where the project, just like works at all. We're still very much in the first development batch. I'll be a bit more strict about commit etiquette when we are at a point where we have something that works, and then we start doing incremental changes, like in small feature branches rather than just like everything on the dev branch. Okay. So something I wanted to do as well that I have not done yet. I think it would be good to have. I have an internal thing here. I probably want to have something better for we have encountered an internal compiler error. And this should be because basically there's a few places in the code where whenever we encounter something that is theoretically not possible, but that impossibility cannot be captured by the type system, I just panic. Like, oh, here we have an identifier that is like empty, for instance, which should never happen, and we have a bunch of things in place to prevent that from happening, but the type doesn't capture that. Hi, how are you? Yeah, things are going great. This is a chill stream this evening, so just doing cleanups basically. But yeah, there are situations where we encounter something where, like, okay, from a logic perspective, this should never happen. However, the type system that we're using cannot capture this. And those places are the places where I feel like it's okay to panic, because that's a logic error. This indicates a serious bug in the code. That thing should never have happened. It's not something that can be triggered in theory by invalid input from the user. For now, the way I've been doing this has been to do air ice, which means just panic. And I think I want to do something a tiny bit better, or at least at some point I will want to have something a tiny bit better, which is like having a proper message with formatting and everything. I wonder what the GHC internal compiler error format looks like. I wonder if I can find an example of what it looks like. That's not an internal compiler error, that's just a normal thing. I'm looking at random things to try to see if one of them contains. That's a clang error, that's a linker error, that's not a. Yeah, I'm curious to see. I'd be curious to find what a internal compiler error looks like in GHC. It's been a long time since I've actually managed to get one myself by compiling stuff. I guess we can figure that out later. For now, what matters is where I will want this function to be is has called stack, so that a called stack can be added for debugging purposes. Actually, how does that work again? Has called stack. So error provides a stack trace. Okay. I will probably at some point want to control that and not use the default formatting of error, but I think for now that's fine. So yeah, I will want port GHC stack. I will probably want context and error message. And how do I do elegant string formatting? I do have a prettifier thing. I do have a dependency on the prettifier library. Maybe I should use that. Or maybe that's not something I want to actually work on this evening, and maybe for this evening it's going to be enough to do an error. And this is going to be, I'm going to concatenate a bunch of strings. Not concat, unlines, I think it is. just unlines. Yeah. Okay, and this should also print a a call stack. Perfect. So now what I can do, and might do this in another window, which is not gonna have my usual formatting, but that's fine. I can git grep an air ice. Okay, that's all of those files. Okay, open that in a new Emacs. Make that big so that it's readable on stream. Okay. And now I'm going to replace all of those errors with a call to the report ice, basically. So that's going to be a internal, how is it called again? Internal singular ice. Okay. I'm tempted to then add a hlint rule to forbid the use of air in the code otherwise, as in every single panic should be indicated by this function and therefore should provide a call stack, a context, an error message. Yeah, I might do that. Okay. So this is going to be a report ice. I don't have access to... I don't have access to the file name, so I can't say passing thing or something like this. That's fine. Yeah, this one is absolutely impossible if I don't have a bug in the code. So this would never happen. Famous last words. But it's still good to be explicit. Int literal is not an int. Those come from the fact that I will match in the parser, I will match, where can I find an example of this? Let's make this a tiny bit bigger so it's more visible on stream. Up, there we go. In the parser, if I go for literals, where are you? Ah, there we go. Here is, I've matched an identifier. So I've matched a token, which is an identifier. And then, but I need to extract the identifier out of the token. But since I only have the token, I need to do a match of like, hey, actually, what kind of token is that? This will only successfully match something that happens to be an identifier. But this function still sees a token and therefore still needs to do a match. And therefore, I have to, at the code level, handle the possibility that we're matching something that is not an identifier, even though that's not possible. So those functions should absolutely never fail. But if they fail, it means the rules have been written wrong. and that's an internal compiler error. Okay, there should no longer be any error ice anymore. Perfect. Why is this one? Aha, okay. So this is when I process, do the analysis of a module, I do type checking, name checking, simplification phase, and so on, and then I do the instantiation of generic functions that can be instantiated as part of this. This is basically, oh, I have said that, like, oh, there's a min function that's generic, but needs to be instantiated on characters in the case of this module. But when I try to instantiate it, the function is not found, which should never happen if my state is correctly handled. And since in this case it would not indicate an error from the user, it would indicate an error from the compiler's perspective. That's an internal compiler error. Do I want to include? Yes, I probably want to include the name of the function in this. Okay, so that's one more that has been fixed. Is that the only one in this file? Okay, good. What do we have? Do we have here? We have this is something where I'm checking the type. Okay, I call resolve type with, and I provide this go thing as a resolve callback. Actually, I don't like this formatting. It should be like this. Anyway, and I guess this case is I have found a definition for the type that is neither an enum nor a struct, which means I have found a definition which is a constant, a function, or a type alias. Type alias should have been unfolded into the actual type. And since I am trying to resolve a type, function and constants are not possible. So here, this is an internal compiler error because I end up in a case where and that I end up with something which is not a type. I have a definition. And I probably will want to add, it will be unreadable, but it might be useful for debugging purposes. Oh, do I want to include details? Yes, I might want to do that actually. Okay, so if I go back to here, this will also get a maybe string, which is going to be the details. And then we're going to do there we go. Actually, this is going to be a maybe list of string, which means I can just do a fold details. There we go. Or actually, maybe this list of string is used less. Maybe this is a list of string and it's just details. There we go. Okay. So there's a few places that I'm not going to compile, and that's fine. I'll catch them when I get to them. So here the context is struct type resolution. The error is unexpected definition for struct. And do I have the name? Here I'm going to include that in the details, I think. And the details are going to be a list. And the first thing is going to be struct type. And I'm going to just show the path info, which is the argument. And the definition, what did I find? I found this definition here. I'm going to show that. Okay. Here, this is, I am trying to resolve a constant value and resolve path and resolve value with. So resolve value will have already checked that I have something. So this is a case where I did not find a definition for the thing I'm trying to resolve, which I think cannot happen. Resolve value with. Yeah, this expects a name. Okay, so since this cannot happen in the callback to... Actually... Oh, no, okay, I could introduce a new thing that doesn't have this. Do I want to do that, actually? Wait. Ah, yeah, here, and I have the info. Yeah, I have a bunch of those cases where... it cannot be a maybe. For a typed expression, I think it's all of the resolve value with. I should document those functions. This is something I should do as part of the streams as well. Get type name, get value name. Okay, no, it makes sense for them to be possibly... No, it makes sense for some of them to be nothing. A type parameter has no unique name associated with it. Yeah, no, that makes sense. So it is at the callback level that I have to decide, does it make sense here to get something that is nothing? Since I'm trying to resolve something that is a const value. Yes, that is a value that appears in the constant. So all of the cases that would yield something that doesn't have a name, such as a type parameter, a function parameter, all of those are impossible because we are in the case of a constant. So indeed, that is an error. That is impossible. So that's indeed reporting a nice. How did I format this? Struct type resolution. This is going to be const value resolution. The error message is going to be no definition found. And the details will be the name on the path, actually. And that's it, since there's nothing else to match the definition. Okay. Those are errors that can arise from invalid code from the user, but they don't result in an internal compiler error. They result in an error that is surfaced to the user, which is fine. Okay. Here, what is this? Here, this is a value in an expression, and I found something that doesn't have a definition and is not any of those cases. So it's not a function argument, not a delete variable, not a built-in function. That means it's not a top-level declaration because otherwise it would have a definition. It means it's either a built-in type, a placeholder. Yeah, it's something that makes no sense. Okay. So God damn it. When I find some... Oh, actually, this is... Oh, it's in this case. So this is the case where we've tried to find the built-in function information, and there was no information associated with it, which means we've managed to have a built-in function that doesn't have a definition. Okay. Okay. Okay, that's going to be the same. And here, this is the case where I match. Okay. Wait, is this one even still possible? Which one do I not match? Placeholder, probably? Yeah, that's what it is. Okay, that's one more. I could have avoided all of this if I had, from the start, used a proper function, but, you know, such is life. So this is part of... Let me check that resolve function call value is named correctly. Let me go back to the analysis. Core resolve function call value. I guess it makes sense because it might not always be the name of a function, since we theoretically have function pointers. So it could be a pointer to a function. Function value resolution, and this is incorrect role for function value. And I can get the role here as well and add it to the details. I'm gonna copy this version. Okay, so here, what do we have? This is this one. I can just copy. And paste here. There's a function value resolution, no definition found for top level declaration. Okay. And here, this is incorrect role. Oh. It's this one. Wait. Yeah. And it means this one is wrong. This is not a role. This is... no definition found for built-in function. Yep, that's where it is. Okay. I do have more here. I do a pure from maybe. I can replace this with a from definition on nothing report ice. This is... I'm trying to do the analysis of a definition. And the error I get is a from definition here, which is, okay, this is a tricky one. This is a weird one. This should absolutely never happen. Resolved definition type doesn't match past definition type. So this is like I try to do the analysis of a function definition and I end up with a constant definition on the output. That should absolutely never happen. Okay, this should absolutely never happen. Okay. Do I have more? I do have more. Okay. Oh, wait. No, it's fine. Okay. Can I just use a on nothing here again? Yeah, I think I can. And this will be a report ice again, where the context will be... I don't know what I'm doing in this context. Oh, wait, no. It doesn't matter what callback I'm doing. It means... Okay, this means I did find a name for a thing, but I did not find a definition for it despite having found a name in the foreign definitions, the cache definitions, or the local definitions. Does that make sense? I suppose if something has a name, it should... Wait, I'm not sure about this one. I am not sure about this one. I feel like it should be possible for something to not have a matching definition. If it doesn't have a name. Oh, wait, no. This is not a role. This is a name, which means it is something that is associated with the top level. Yes, okay. So it's something that must have, if it has a name, it must have a definition. Okay. So that means we did not find a definition in the imports, none in the cached thing of the things we have already resolved, and none in the local definitions that we haven't resolved yet. So here, name resolution. The error is could... what's this? thing I've used so far. Incorrect role definition. No definition found. No definition found for a given name. And the details will include a name, and that's about it, I suppose, because we didn't find anything else. Okay. Partially resolve function type. This one is fun. So this one means, so we have found a function that we are trying to resolve. Like, oh, I'm calling function foo and with a type parameter int, something like this. And I want to find it. So even if I don't fully process the function at this point, because I need to be able to like at least check the types for recursive functions and so on, I need to try to see, okay, is this a function I know? And I try to instantiate, as in, okay, if this is a generic function and it has type parameters, I need to register it for instantiation and maybe instantiate it right now if I can, or otherwise register it for later instantiation. If that happens, if I detect that it is a generic function and that it needs to be instantiated, I will get its true name, which is a new name that doesn't point to the unique declaration, but will point to the instantiated version. And I am updating the name, the path I have for this function, as in I was pointing to function foo and I want to actually make it point to foo of int, the instantiated version. So I update the path name to the true name. And here it means I found something, a function which is neither a top level declaration nor a built-in function. That makes no sense. No way I have arrived that late in the code without finding something else. Therefore, report ice. This is generic function resolution. The error is unexpected role for generic function. And the details will include the name, which is the true name, and the role, which is the role. There we go. Now, do we have any more? We do. What is this one? Okay, so here I found a name that points to an enum. So I'm trying to like resolve an enum value. I have a name that points to an enum. So I check first that it actually points to an enum, because it could point to something else which would be wrong. But I have two different kind of names that point to an enum. There are the constructors and there's the type name. So what I check first is, well, did I find the type name? And for instance, I have an enum color with constructors red, green, blue. If someone does let x equals color, color will point to the enum, but will not be one of the values. It will be the constructor type name, which would be incorrect in this context. So that's this handling here. However, if I found something that points to an enum and is not the type name, then it must be one of the constructors. There is no other thing that is registered with that name in the scope. And therefore, I should be able to like get the int value of the enum thing by looking at what index is it. And this is, I did not find it in the list, which is an error. And I can do enum value resolution unknown enum constructor. The path will be the resolved path, and the type will be. Do I have the type? But I have the enum info. That's fine. Okay. I guess I can do it like this. Okay, and that's all for air ice in this file, I think. Yeah, that's all. Perfect. Another core. There's going to be a bunch. Wait, this doesn't match all cases, does it? Oh, no, it does. Okay, yeah. This matches a list of 0 element, a list of 1 element, and a list of at least 2 elements. Okay. Yeah, this one is I did a group on the parameters, and I did not. Wait, that means the list of parameters was empty. That's the only possible case. That seems like a valid way to call this function. Yeah, if I do a group sort of an empty list. Oh, I'm wrong. This is that I did a group sort and I got a list that contains an empty list. So group gave me an empty list as part of the elements. That is not possible. Because group basically groups together elements that are the same. So if I do A, B, C, C like this, and I add an extra A here to justify the sort, I will get A, B, C, C, because it groups them together. So having an empty list within the result would mean getting a group that contains no element. That is impossible. To an extent, this shows a problem with the definition of the group function, because it should actually return non-empty lists, because it makes no sense for the it makes no sense for the list within to be empty. So that is something that would be, that's not even a compiler error. This is a language error. This is like a Haskell error. If that happens, so that one would be this one really suggests that something went very, very wrong, because that's the group function, the built-in, the prelude, the one in the prelude doesn't work as expected. Yeah, no, that would be weird. I still have to match this because otherwise I'm not matching all possible cases. I was going to say I could match I have more than one element versus I have one, because that's the case I'm interested in. But check that I have one, I need to also check I need to check the case 0 for the compiler to be happy. And that is not something, yeah, I need to check that case. And therefore, yeah, I need to report an ice. Okay. Here, what do we have? Okay, so here this is, I've done the resolution of a struct type because I found a struct expression within. I have found a struct expression within a constant. So I found something which is like creating a struct value, which means I call check struct type that will give me a few things, some information about the struct in question. This function will yield a fatal error if the name of the struct is not found, or if I found the type definition and it happens to not be a struct. So all of those cases will be handled for me. There is, however, a possibility for this function to succeed and return nothing, which is when I don't have enough information to know whether the thing is a struct or not at this point, and this only happens in one case, when the type name is a type parameter of a generic function, and since the function has not been instantiated yet, I therefore cannot know yet what the type of the struct will be. It will depend on instantiation. This is in the context of a constant, and constants do not have type parameters. Therefore, the only case where this function could return nothing cannot exist. Therefore, if it does, something went completely wrong. And we can report an internal compiler error. This will be const expression, I suppose. Yes. The error message will be struct definition not found. And the details will include the path, which is the struct type. Let me just check actually something. If I go back to my AST and I go to struct expression, yes, the first argument is indeed the path to the struct. Okay. Okay. So that's what this error means. And here, what does that mean? It means I found an expression that cannot be compared. But does that mean that the type error would compare expressions? Where is this used? It's used here. Okay. So here, this is a case where I have done the type checking, so I know that the type match. I know I'm in the case in the constant where all of the types are known. There is no such thing as a placeholder or a type parameter. which means, by definition, being in the case of a constant, I must have been able to resolve the value at this point. Because if it's another constant, I can just inline it. Therefore, when I am in this case here, if those things don't match, it means I don't have a compile time known value, despite the fact that I am in a constant and I've done type checking. Okay. I need to handle the case of strings, however. Even though I don't have string handling in the language yet, there is a bunch of things for it. So here that would be a mistake not to handle this case. But I can leave it as unimplemented, which is something I don't have a function for, but unimplemented has call stack returns an A, and unimplemented is gonna be a simple call to error, not implemented yet. There we go. Which means I'll try to replace all uses of undefined by unimplemented. Okay, so this one is wait, I don't need to match this because I have E1, E2. I already have them. Okay. Const expression analysis. The error that we have here is unknown compile time, unknown or incompatible compile time values. And the detail will contain the left-hand side, which is E1, and the right-hand side, which is E2. Okay. Here, another ice. Okay. This is the case where my value is of type enum, but its representation is not an int. Doesn't make sense. Enum value representation isn't an int. Okay. Oh, this is gonna invalid exp just to avoid shadowing something else. There we go. What's the next one? This one. This is also a cast. Okay. Actually, I have introduced here a report cast error thing. Report cast ice. this is going to take as an argument. What does this take as an argument? This takes as an argument. This is an expression resolved and returns some random a, it doesn't matter. There we go. Which means here I can do a report cast ice with the invalid expression. Oh. There we go. And I can do the same thing here. Cast error, okay. Here, what do we have? Resolve struct type. Wait, this is in the case of... I'm still in the case of a constant. Am I? Yes, this is still in the case of a constant. I thought I had the struct expression already handled. Oh, this is where I'm doing a check struct type for, okay, for a comparison expression, okay. And this is when I'm actually going to get, okay. What's the difference between resolve struct type and check struct type? Resolve struct type gives me a maybe. It might fail, that's fine. And check struct type... It has the exact... No, it does not. Okay. This one takes a name. So, okay, I have something that I think should be a struct. Let's find what it means in this context and check that it is a struct. But check is, I have already resolved this as a type. I already know it's a type, it's fine. But now I want to make sure that it is indeed a struct. And in fact, resolve struct type resolves the type and then checks it with check struct type. That's the difference. Okay. And that's why, of course, okay, that's why resolve struct type gives me two things. It gives me a pair of the path and the maybe information, while check just gives me the maybe information directly. Okay, that makes sense. So that means, back to here, this is the same error as trying to resolve a struct for the context of... Okay, I'm hearing some music coming from somewhere, but it's not from my headphones. So it's the same as this one, basically. We are trying to find a struct at compile time, and for some reason we couldn't find it. Okay? And again, the reason why this is an internal compiler error, despite the fact that this returns a maybe, is this maybe is here to accommodate for situations where it is valid to not find information about the struct yet, which is only the case for generic functions that are trying to do a lookup on a type parameter, where we don't know what it is until it is instantiated. However, constants do not have type parameters, meaning this maybe cannot happen in the case of a constant, hence ice. What do we have here? Ah, yes, I have the addition expression handled separately from all of the others binary int expression because at some point plus will also support string concatenation when I have strings. So what this does is first it checks the type. This is a bit inelegant because this is like checking that it is either int or string, basically. Like this will have to be rewritten. Actually, didn't I? Hey, yeah, I took a long break in August. Some of it was planned, some of it was not. But yeah, I took a long break, but I'm glad to be finally back. Because this ugly thing for checking the type of an addition, I think will not work properly when I want to add string concatenation. But yeah, I some of my time off was vacation, which was great. Some of it was being sick, which was not, and some of it was playing Silk Song, which was great. So yes, everything good now, at least. So yeah, this for constants is ugly, and I think for functions I did something different. Analyze statement, analyze function call arguments, analyze function expressions. There we go. What do I have for addition expression? There we go. There we go. This is a lot better. This is analyzing recursively and then check are they both ints, are they both string, and otherwise handle the case where they don't. Yeah, okay. So I think I'm gonna reuse this for the case of constants. I think it's better. So this would be the recursive go analyze this expression in the context of a constant recursively. And then the purity is not something that I really care about in the context of a constant, I guess. Because it will always be pure by definition. But yeah, I want to handle okay. Those are both int expressions. I can return, I can compute the value at compile time. I have a case for later for strings. And I suppose if they don't match, actually, I think this is wrong too. Yep, this is wrong too. This is wrong because this will allow doing int addition on enum values because enum values are represented as an int expression. And since the type checking is performed since the type checking is only performed after I've made this case, it means I will allow, which means I think if I try it now, do I still have somewhere in. No, I don't have it anymore. Okay. This would be in. don't remember where it is. I'm looking for a file. That's gonna be... Wait, there's nothing else in... Oh, it's of course it's in stack work, not in this new style. What I'm trying to find is the latest compiled version of the binary because I don't want to compile because I'm modifying code at the moment. Should be in dist somewhere. Build. There we go. That's the latest compiled binary, and if I call that on test3 main, it does compile. Okay, perfect. And if I introduced a const broken, which is an int, and I have an enum color with red, green. That's not the proper syntax. What's the syntax again? What is the syntax of my own language? Docs, reference, enum. Okay. I think this is broken because this will allow red plus green as an int. Lexical error, so I have something broken in there. I mean, it kind of makes sense, but this is still not something I want to allow in the language. Wait, so what is broken here? There's a lexical error. Is it the passing of the enum? Yep. I have used enums, right? Okay, lexer. So this was a lexical error. Okay, so what happened here? I tried to pass an enum. Wait. Yeah, this is not correct. This is not pipes. It is commas. My reference is wrong. I am fairly certain that if I go look at the parser, enum, an enum declaration is, yep, a comma list of things. So my reference is wrong. That's not what pipes are used for. So this is the correct syntax. Okay. So I can close this, I can close this, and I can do this, and this should be broken. Encountered, yes, no semicolon at the end. Okay, so now I do get an error. Interesting. What is the error I get? I get diagnostic location, error wrong type. Oh, that is cursed. Oh, that is extremely cursed. Okay, something is absolutely wrong there. because the error I get is that the type of this is red. It's not even color. It says that the type is this is red, which is incompatible with int. Yeah, this is starting to be a bit late for me. I usually start like I've started almost 4 hours ago at this point, but glad you could drop in. And yeah, now unless like this, I have no vacation plan in the near future, so unless I get sick again, the plan is to resume normal stream Tuesdays and Thursdays. Okay, so this is deeply, deeply broken. So what I got here is that the inferred type of this was completely wrong. And I think if I cast this as int, it will compile just fine. No, it doesn't. Okay. The name is red. That is so, so wrong. How do I get a red as a type name? Deeply, deeply broken stuff. Okay, so let's see what happens. What happens is... Wait. Oh, no, it's fine. No, it's fine. Okay. Well, it's fine. There is an error, but it's not where I thought it was. I thought it was a problem of... I thought it was a problem of I am matching on the representation, not the type, but that's not the case. This int expression is not just the representation. It is, unless I'm mistaken, it's probably going to be built in. An int expression is a R value expression of type int. So there is a type checking there. I am checking that I have a thing of type int. So it's not I'm matching the representation, I am matching the representation and the type. So that was fine. The error was not where I thought it was. Wait, so I go back to constant because that's the one that's broken. Addition, there we go. Oh yeah, no, okay. This one is the one I'm That's the one I'm doing at the moment, the one that's broken. And here is where it happens. This is the error that fires. And I get a typed expression with something that is resolved as the wrong type. That's the thing that happens. This is the error that I got. Okay, so that means that doing an enum expression, I have a bug in the enum expression where the type... So resolve const value, that is in core. Oh, it is in context, not in core. So here I found a enum value. Aha, this is what it is. Verify enum value. Here is the path, which I assume is the type, but that is not the case. That is the path to the value. So here, if I'm using the resolved path as the type, that is incorrect. So here I need to find... So I need to adjust the path so that the last element of the path points to the... Okay. So that would be resolved enum resolved type path. Is gonna be the resolved path that we're gonna modify so that the path name is modified by applying a function Wait, what's the syntax that I want? I want control lens setter. Do I want to modify or do I want to set? I want to set, I think, and I want to set it to init of the name full path. Wait, no. Why do I have a different path info and a different name? I think it's just setting the name as the resolved path. I think that will be correct. Need to check just in my path. Yeah. Wait, no, this is a roll. Okay, so I need to do a case and I will have to do an ice here. So here what I want to do is I want okay. So the resolved path will be it will be pointing to an enum, so it must be pointing to... Could it be not a top level declaration? Could it be a... No, because I have an enum value, so I know that I have found an enum, so I know I have something that points to a top level declaration. So here it must be a top level declaration, and I replace it with a top level declaration with the true name, the type name, whatever this ends up being. If I have anything else, that's an ice that we'll have to fix afterwards. And now is the type name just this name? This depends on what name I associate with enum constructors when I create my scope, which is done in monad, I think. No, it is done at the top of core. create local scope. There we go. And definition identifiers. Yes, the name that will be associated with something. So the path. So if I'm saying red, it will be pointing to the name of the definition. So it will be pointing. So yes. So here in context, the true name is just name. Okay. Okay. In this case, I will probably want to have the name instead, since I have it. Okay. Except this is the wrong syntax. I think it's this. I think it is percent tilde. Yeah, that's the one. Okay. So now I'm going to need to make this compile despite the fact that I'm in the middle of a change. Yeah, I'm going to revert the changes I've made here. Okay. Let's try to compile that. Wait, has called stack? Oh, it's with a capital S. Plus details. Okay, so I have a few places in parser.y where I'm using report ice wrong. Identifier literal is not an identifier. Here, no details required. Those are... I guess I could... No, I can just give this and just like... Token is show token. Okay. Okay. I'm gonna need access to... which I'm gonna copy because there's gonna be a bunch of files that are gonna require it. Show role. Role isn't matched. That's gonna be this. Wait, no. Up, there we go. I think there's another thing M. Aha, this is a bit different. Is it because... Ah, yes, of course. This is a maybe of a monadic action. So yeah, here this is definitely a from maybe that I want. And I'm going to do a flip from maybe action. There we go. Show of the roll. Could not deduce. Show annotated definition. Ooh, this is annoying. Can I fix this? Resolve callback. So I am running into the problem that I run sometimes into, which is I am stacking a third thing I'm trying to fix on top of the stack. Let's see how this goes. Context, I think, has access to the AST. Yeah, there's no... Okay, perfect. So I think it is fine to add show constraints here so that the values of whatever the phase of the thing I get, I can print them. That should be fine. Ah, yes, of course. And here I also need show constraints of P here. And I'm going to need it here as well. Show constraints. Binding for def. Perfect. That's a good one. That's a good error. We like this. Incorrect definition. Up. There we go. Perfect. Now we are moving here. I need to add this import. That's missing. So I've popped the number 3 thing on the stack, which is resolve having show for my internal compiler errors. That's done. So now I need to make sure I have fixed the type error for... I have fixed the type error for enums. Then I can make sure that I fix the constant type checking for enums, for addition of constant values in the case of enums. And then I can finish the thing I was doing for internal compiler errors. Oh, here I want to change this. I want to change this to be report eyes function instantiation. The message is function definition not found, and the details contain name and the name. Okay, so this compiles. So now I can check that when I do a red plus green as int or anything like this, or even red plus 3, the error message I should get is color is not an int rather than red is not an int. Okay, what do I get? I get several different diagnostics. Okay. Error wrong type. I have an int. I'm expecting an int. And I got... Nope, I still got red. What is happening? And why do I get more than one error here? Okay, so here, the function that is broken is in core. It is in the analysis of a function of a const value. I have, in the middle of all of this mess, an addition expression. Okay, so here I try to analyze the left-hand side. Of course, yes, I get several error messages because I try to validate the left-hand side and the right-hand side. So I get an error on the left-hand side because it should be an int and instead it is the wrong thing. And then I get an error because the thing on the left doesn't match the thing on the right. Yes, that's what it is. So that's the second diagnostic. Okay, so I still have the problem that the type name is labeled as red, which is wrong. So let's go back to context. Let's go back to resolve enum. Oh, wait. Let's go back to context. Let's go to resolve const value. So here I find an enum definition. So I have to verify the enum value. And here, this is where the resolved type path is somehow wrong. So here, it's going to be time for some good old debugging. Trace show m. Give me everything. I'm going to want to show the resolved path. Trace show m the name. Trace show m the info. And trace show m the resolved type path, which means I'm going to need to have import debug.trace. Okay. Oh, wait, unless I'm still using an old version of the code? Okay, no, I'm not. So, the resolved path, the path to the thing I'm currently analyzing, is indeed main red with no type parameter. That is correct. Aha, and the name is main red, which is wrong. The enum info is indeed color. And of course, the modified path info is indeed red because the name I got for the thing was red. Okay, so why is the name I got Why is the name that I got red when red should be pointing to the unique name of its own type, not of its own. Oh, wait. Maybe that's intentional? Okay, so let's go back to core. Initialize local scope. Create foreign scope, create local scope. There we go. So for each definition, for each identifier. Oh, yeah, of course. Yeah, no, okay. Yeah, I'm creating a unique name that points to that unique thing. So a constructor will have a name that points to that specific constructor. Do I want to change that? No, I think it makes sense. The top level declaration of red is not the same thing as the top level declaration of color. That does make sense. However, so I think this makes sense, okay. However, when I verify an enum value, this path points to the constructor. Therefore, this must be the name of the enum. It must be fixed so that the name points to the name of the actual type. I don't have the name of the type from the name of the enum, but I can reconstruct it. This will be, as a result, a top-level declaration that points to the init of the full path of the name. It's a non-empty list. Non-empty. What's the operator to add something at the end? There is init, which is what I want. Prepend, but there's no append at the end. Okay, that's fine. Oh, there is append. But it's for, okay, non-empty lists. Okay, that's fine. So I'm just going to do this, and I'm going to add pure of the enum name. Okay, that's a bit ugly, but that should fix the problem. When it compiles, of course. So here this is I am changing the name of this thing it's pointing to. This is very, very ugly. Maybe actually I should have the name always be pointing to the type, and I make the distinction based on the context. No, I think I want this to be the unique. Yeah, yeah. Because maybe I will have different symbols. In fact, something. Yeah, no, I want it to be the name pointing to the thing, which means I need to be able. Okay, so I'm gonna introduce a new function for this. So here is where I'm going to make a dedicated function that encodes this restriction. I want to be able to always construct the enum type name from the constructor name. So I have a given identifier and I have a constructor name. The result of this will be that the this is not going to actually need it. This is going to be, I'm going to use the name full path lens. Wait, where's the lens for this? Oh. There it is. Which means I'm going to need template Haskell. And I'm going to need control lens. And I can probably get away with just control lens th. Okay. No. Okay. So here, name full path, which is the lens to this thing. And I am modifying it to replace the last element. And what I'm doing with it means, given some path p, I'm going to do everything but the last element, which is always going to be... Is that going to be a list? It is, yeah. Ah, it's annoying. It's fine. I can guarantee that the thing is not empty since I am always appending something at the end. How do I create an empty list and I'm okay with it? Yeah, from list. So this is going to be an NE from list of everything but the last element plus one element, which is just going to be the identifier. There we go. And I can make that a list. Okay, I am going to need import data list non-empty qualified as NE. There we go. So now I have this horrible function enum type name from constructor name, which means here in context, I can change this and say that the resolved type path is the resolved path on which the path name has been changed to be the enum type name from constructor name. And here I know that the identifier is enum name. Okay. There we go. Variable non in scope. That's because indeed I am using lenses. I need more than just th. I still need to do the thing. I still need to do the thing where I am assuming which I'm going to make this assumption here, enum role from constructor role. I'm going to make the assumption here, which is here I have a role and I want a role in the output. And this is going to be a case of if I do have a top level declaration, then I do have a name, and I can return a top level declaration in which the name has been modified it's constructed that way. It's gonna be this is how do I make this in a readable fashion? This is going to be a top level declaration where the name has this name full path. And its name parameters are just those ones unchanged. And in the case where I have literally anything else, ice for now. And then as a result, back in context, the result path and the path name, and here I can apply enum role from constructor role. Okay. That was ugly, but hopefully this should be fine now. Which means I can unstack this bug from the stack if it works. Okay, that compiles at least. And so now I am getting an error for, so okay, here I was indeed pointing to red, which is the constructor, with the name red. The enum info is the color, and the fixed path is now color, which means now my error should be an error wrong type, because on one hand I have a built-in type which is an int, and on the other side I have a top level declaration which is color. I no longer have red as a type name. Okay, so that's fixed, which means I can go back to the thing I was doing in the analysis of addition in the context of a function expression, which is an analyze function expression, and I go all the way to addition expression. Here, this code is different from the one I have for constants, and I want to fix the one I have in constants. So here I analyze the thing on the left and the thing on the right. If they are both int known at compile time, then I can I can do the addition at compile time. If there are two strings, I can concatenate them at compile time, but I don't have string support just yet. Otherwise, if they are not of types and value I know of at compile time, then rather than having a bunch of different things, if the left hand side is an int, if the left hand side is an int, then I can do, I can report an error if the right hand side doesn't match an int and say that the result will be an int. I'll be able to do the same thing for a string, and otherwise, if the thing on the left hand side is neither int nor string, I can't decide what type of thing this is, and I have to report an error. Okay. I think, to avoid having the multiple errors I have in the case of constants. So I think I want to do something somewhat similar. So in the case of constants, which is where I found the bug in the first place, addition expression, there we go. I think here, yeah, since I know at compile time the values, there's no problem of like not knowing the thing. I think I'm gonna copy this and do this in the case of a constant as well. So left hand side, I analyze recursively. Right hand side, okay. Purity, I don't care because this is a constant. And either they're both int, perfect. I can do the addition and return the pure int expression, perfect. Or it's two string expressions and I do the concatenation, perfect. If it is not, yeah, okay. I still need to handle the different possible cases. As in, is the type of the left hand side an int? And in which case I must say, yeah, okay, I'm gonna do this slightly differently in the case of constant. So case left hand side of int expression L, do something. String expression L, do something. Other kind of thing. If it's the third thing, this is a fatal error. And I copy this. I think the one I have here is better. I'm gonna copy this for now. Even though I'm gonna do something slightly different. Wait, I was in the middle of it. There we go. So here, I copy all of this. This is what I want. I'm expecting either int or string, and I got whatever is on the left, because I did not get an int or a string with my constant time, so compile time value. So I got a type which is neither int nor string. Maybe I got an enum, I got something wrong. Okay. In the case where something is an int, I can do a case of the right hand side, and if I also get an int expression, and perfect, I can return an int expression known at compile time, which is the sum of the two of them. If I get anything else, then wrong type, I am expecting the type of the left-hand side, which I know is int in this case, but this is slightly... But I got the type of the right-hand side. For string expressions, I can do the exact same thing, except I don't want to handle them yet, so I'm just going to do the same thing and then comment it out. If I found a string on the left and I found a string on the right, that's a string perfect. And if I find anything else, then I'm expecting the type of the left. I got the type on the right. That is wrong. And if I did not get int or string, then my error message is I should be having either of those, and I didn't. And this removes an ice from the thing because now I have handled all of the cases properly. Okay. The only thing is unimplemented here, and all of this gets commented out because I don't have string support just yet. Okay, this should be a lot cleaner. Except string expression, yeah, not. I'm just gonna... Because strings not handled yet. Okay. This compiles, good. Perfect. And now if I test this, broken is still broken. Oh, I should remove, I'm gonna remove in context, I'm gonna remove debug.trace. Trace show is here. Let's remove debug information because we fixed the bug now. And hopefully with that, I'm done unpacking things, like popping things from the top of the stack, and I'm back to what I was doing. And now broken is the error I get is wrong type because I expecting an int and I got a color. Because in main here I am doing red plus 3. That is not correct. And if I were to do red plus green, I would get the same thing. Wait. Yes. And if I were to do... I don't have strings, so I can't test that. But yeah, okay. So now this should be fixed. I'm no longer allowing like enum handling in addition is done correctly. There's no longer a bunch of different errors, and the name type name in the error is now properly colored. So this is fixed. Okay. Which means I can go back to what I was doing, which was to... which was to go through all of the places where I have a hard-coded I have a hard-coded error and replace it by a much more clear call to my new function for internal compiler errors. There we go. So I should still have, there we go, there it is. Here I have an error ice. That's a function I've just added. And this one, ooh. So this is an ice. The context is, this is going to be for enum value resolution. Well, enum type name resolution. The error message is going to be tricky. Because the error message here is enum constructor role isn't a top level declaration. That means I found a way to have something that points to the constructor of an enum, like red, green, blue, that is not a top level declaration. It's like a variable, a variable or a function argument, something like this. That should never happen. And the details, I'm gonna add that the enum type name is this identifier, and the constructor role is this role, which happens to not be. Okay. Okay, so that's one more internal compiler error handled. Okay, back to what we were doing before the whole enum debacle. What is this internal compiler error? How can I replace this with something that is a bit more readable? So I am doing the analysis of the field of a struct. And I'm saying that I should have. Okay, so here I am assuming that this hash map, which maps some information to the name of a type parameter, which is the type that has been found, if any. It could be nothing. It could be a placeholder. Like, it could be wrong, but like it's something that points to like what is this thing pointing to in the current context. This should always be. This should always contain something for every type parameter of the type of the struct. If it doesn't, something went wrong. If it does, it means I can always do a lookup here. I could I could check the assertion ahead of time and do a partial lookup here, but I think it's cleaner to actually handle this properly. So here, this will be a report ice. This is struct fields analysis. The error that we encountered is no type information for type parameter. And the details we want to include the parameter name, which is param name, and I want to include probably known parameters. I think I did this wrong in a few other. I have to check my diff, which would be, so show, of course, which will be the param mapping. Okay. I'll quickly check that actually. No, okay, this is correct. For the places where I have more than one, no, okay, that's correct. Okay. Okay. Okay, that looks correct. Okay, it's all correct. Perfect. So that's one more internal compiler error handled. Here, what do we have? This is analyzing the function call argument, and this is the exact same thing as our previous one. We have a hash map for the parameters, for the type parameters, and we're expecting it to contain something, even if it's just placeholder. We're expecting it to have something for every type. If it doesn't, then something went wrong ahead of this and we cannot continue. And that's an internal compiler error. I can probably just do it like that. So this is function call arguments analysis. No information for type parameter. Param name, param mapping. Okay. Oh, here there's, however, I'm missing a column. There we go. Let me be consistent with my indentation. Okay. Next. What is this one? So in this one, I am in the context of a function. I have found a function call. Okay. I have found the function information from which I can do things such as checking the number of arguments, and I can report a error function call wrong number of arguments if something is wrong. And here I need to find the true path, which is basically if this was a generic function and I know all of the types and I know how it will be instantiated, then I can find the true name. And in which case I need to substitute it. And here it means I have found a function which is neither a top-level declaration nor a built-in function, despite the fact that I have been able to instantiate it, which means I know which function it is. That is impossible. And I can include here, I suppose, the path to the function I have found. Up, there we go. Okay. Next, what do we have? We don't have any anymore. Perfect. So here, generate full function name. This is the same kind of thing where this is the same thing where at this point I'm expecting to have a full type mapping of the type parameters, and if I don't, that's an internal compiler error. How did I... How did I write this error message for the other one? No information for type parameter. There we go. No information for type parameter with the known parameter names and known parameters. There we go. And here, this is another kind of error. This is a bit more subtle. So here we are trying to do a generic function instantiation, and we are at the point where we have decided, okay, we can instantiate that function. That means we know all of the types. We know the function, we know the type arguments. And yet we found a type that is neither a built-in type nor a top-level declaration, which means we have a type that is not actually concrete, which is wrong. So type parameter isn't concrete, and the detail will be do I have... No, I don't have the name of the parameter. That's fine. But that's fine. I can just put the path. The path will be the path name here. Okay. Okay, here what do we have? This is still more of the same, where if we get... actually rewrite this to be like this. Here, if we have nothing when trying to find a thing, I'm gonna copy it from no information for type parameter. There we go. That's exactly what I want. This is this error again. And this is in generic function instantiation again. And this is called mappings here. And this is name. Okay. And that should be the end for this file. Now, why do I have... Okay, so here, this one is fun. I have a way of stacking contexts. This is useful when I have to switch to I am doing the analysis of a function and I stumble on another function, maybe a generic one, maybe I want to instantiate it. I have to set myself in the context of like, okay, what was the scope in this function? New scope on top of the thing, do the analysis there, and when I come back, pop the thing. But that means I have a list of scopes of my context with the scope and everything. And every time I start the analysis of something, I push a new scope to the top of my stack. However, when I'm at the top level of a module, I am not in a given scope. This thing starts empty. So trying to get the current scope when I'm not in a definition will not work. So and I have this thing in current scope, current context, there we go, that will look at the current one and panic if there isn't one. And here I need to... So this is just in the broader context of the analysis. I'm not in a specific context. Attempting to retrieve no context to retrieve. Context stack empty. And there's not much I can add in terms of details because that's just gonna mean somehow we've tried to do a retrieval at the top level. That's never supposed to happen. And since I'm using this with context, with nested context kind of thing, what's the difference between... Okay, so this is a completely new... Yeah, I'm using this with thing that will try to that modify the context to add a new one and then pop it afterwards. So I have this bracket kind of thing. So in theory, I should never do manual manipulation of the scope outside of this. In fact, actually, this is going to be a pain to do, but I'm going to do it nonetheless. I am making lenses for the scopes and everything. I think I'm not going to export the lenses for the context. Those things... There is current context, and that's the only one. I think I am not gonna allow a lookup. So it means I'm gonna need to export everything manually and not export the lenses for the analysis state. I think I'm gonna do that. So let's stack something on top of the stack of things. Is there a way to generate the list of exported stuff? Okay. Let's see. That's fun. So if I do this, and I make sure it compiles, and I go back to stack GHCI. Aha. I should probably stop soon. I've been at this for close to 5 hours. This was supposed to be a quick and chill stream, and I ended up stacking a bunch of things on top of one another, as usual. Okay. Not in scope, it is mappings. Okay, compiles. So now here in GHCI, reload the thing. Okay. Now if I load Piètre stages analysis monad, and I browse. Now, okay, it has every single thing. Oh no, it's perfect. That is indeed. Nice, that is indeed what is exported by my file. Perfect. So here I can do that, and I can do that, and I can do everything that is a bunch of spaces followed by double colon, followed by anything, replaced by comma. Pop, there we go. That's still a lot of things to fix, but at least I have a list. So I probably don't want the details of analysis M to be exported, so maybe just the type name. A scope is fine to have exported. Definition cache, of course. Symbol cache, yes. Function cache, yes. Analysis info. I think I might not want that to be exported. I think having only the lenses exported is enough. So let's try that. I think the analysis state, likewise, is probably something that I don't want to export. And I just want to export the lenses. Except context. And actually, I think any error, new error are also completely internal. Maybe I don't even want to export them at all. Let's see if I can get away with not exporting any of them. Okay. And analysis context, do I want to export that at all or not? I don't know. Let's make the assumption that I don't for now. Those are a bunch of lenses. Which I think I want. And module context is the one I don't want. Oh, they're already here, so I can just remove this altogether. Okay, that's all of my lenses. And let's see if I can not export any of those. Okay, so that's a full export list. Let's see what is missing if I do this. Ah, of course. I get a bunch of things that are not exported. Okay, so here I'm gonna very temporarily do options GHC, no unused top binds. Okay, so here substitute types. Substitute types. Oh yeah, it is in there. Wait. I am an idiot. This is the wrong file. This is the wrong file. I am meant to do this on this one. There we go. And also, of course, okay. So now here with context is required. That makes sense. Ah, that's annoying. So with context, with nested context, I think are needed for sure. With context, with nested context. I think the current suite of functions are things that I want to have in scope. Current. I think the info are fine. I can have them. That's in the reader, that's stuff that doesn't change. So since it doesn't change, it's fine to have. Except for the stack, which is fine. Okay. Module instances, okay, so I am making changes on the module. But I think here, module is the state that is being modified. I think any error and new error should not be in there, and the context should not be in there either. I should not be exporting the lenses for those. Okay. Ensure and a few others, okay. So that's validate, ensure, try. A thing that's annoying is if I'm explicit about things like this, the lenses are going to be generated, but they're not going to be exported, and therefore they are going to be an error. That is very annoying. Okay. Okay, so that seems to be... Aha, analysis state is something that I make use of? I suppose, yeah. But I don't think I want to actually export everything out of the analysis state. I think I want to fix this. I think I want the state to be opaque. So what I mean is I think I will want to do instead definition is going to be use module definitions. Symbols is going to be use module symbols. Functions is going to be use module functions. Rather than doing a get on the entire state, that way the state remains opaque. And for things that should not be changed from outside, I am not accessing the entirety of the state. There we go. Here, analysis info, it is fine to have all of it. So dictionaries. Scope is the first one. Okay. Top level info. I need the analysis info. It's fine to have the constructors exported, and I can include all of the lenses. And this is the inner state. Okay. And that should be everything. Yes, of course. I need the analysis monad to be in scope. Even if not necessarily its constructor. Okay. Oh, of course, yes, I will need run analysis, which is how to run the monad. All of this just because I am automatically generating the lenses and I don't want to export some of them. That's a lot of work. Okay. Now, if I remove this is where I'm going to have an issue, which is I'm going to have some lenses. Oh, unless... Oh, it is smart. Okay. The things that are generated with template Haskell are not included in the unused top binds. Okay, that's good. So now that means that all of the current scope stuff I was doing is no longer accessible from outside of this module. There is no way to access the inner state of the analysis monad from outside of this module. There's no way to do context manipulation other than with context and with nested context. And I can access the current stuff, but I cannot access the list, which reduces very significantly the risk of misuse. Okay. And now I can go back, I can unstack this, and close this one, I guess, and I can just do a quick... I have only one file that still has an error ice, and that's in the assembly. Okay. I haven't touched this in a long time. So here I'm gonna need internal ice, and that's not an ice, that's an unimplemented. Okay, and that's an unimplemented. Okay, and now that should be all of it. Perfect. There is no longer any air ice anywhere. Perfect. That's good. Now, oh, it's not as bad as I thought. That's pretty good. Okay, so I am now going to change this. It's only in two places, core and monad, okay? So now I'm just gonna do a replace of undefined by unimplemented. Okay, and in parsing monad. Wait, why do I still have an undefined there? Oh yeah, of course. I don't handle all of the string escaping because I don't handle strings really yet. Okay. Compile that. And I will need to add a dependency on ice. Okay. And now the thing I want to do. First, if I run hlint on the code at the moment, what do I get? That's a lot of hints. Okay. Yeah, okay, that's a good one. I don't know why I have both. Okay, this is on purpose, so I'm gonna ignore this error. Yeah, this is on purpose as well. I'm gonna ignore that. For the IR, but the IR is non-existent for now, so that's fine. Oops. Core 115. A sequence zip with could be instead zip with M. Yeah. That's a good hint. I will apply that. Here I'm using an F map and it wants to give me... Yeah, no, I don't like this one. Aha, indeed. Here I'm doing a 4, but I'm ignoring the result of it. So a 4 underscore is a lot better. Redundant multi-way if, I know that's on purpose. Redundant dollar. Okay, we are down to main at this point, which is good. Yeah, that's fine. Okay. I'll probably want at some point to clean my hlint thing because there are so many of the hints it's giving me that I actually don't care about. I don't remember exactly how the HLint configuration works, but I think something I will want to have, and I will probably even want to have some kind of like continuous integration test for this, is I think I want to prevent the use of error or undefined in any part of the code except for the one file that defines the ICE stuff. But I don't remember how that works. I might. Ah, there we go. That's something, that's what I want. So if I do this, the only place where error is allowed will be, come on. And the only place where undefined is going to be allowed is going to be in that module as well. Okay. So now if I rerun this, okay, I still get the same errors. Perfect. Aha. Avoid restricted function error. The tests are using error, so this works. Oh, I have here again. God damn it. A zip. I should have committed because now I have a bunch of things. Simplification. I have a sequence of zip with, which is a zip with M. Test integration passing. And I guess here, instead of error, I will probably want to... I am in H unit, I think, which means I'm in tasty. It's fine. Now I probably want to use, instead of error, I probably want to use some kind of primitive from tasty. And I don't know if there's, I know there's one in H unit, but I don't know. Is there, I know that the H unit bind has a report error. That might be the one I'm just gonna use. Okay, so this is gonna be test tasty H unit. And this error is gonna be a report error. Let me check that quickly. Asset failure is one such thing. Wasn't there a report error? No. I guess asset failure is good enough for what I want. It is a throw IO of H unit failure. Okay. That's fine. So here what it means is here that means I will run pass module, which will give me the AST, and on left I will do a assert failure of show, and then with access to the AST I will do a pure from strict of pretty print of the AST. Okay. So now I shouldn't have the... Yep, I no longer have the HLint warning. Perfect. Now I just gonna check the test pass again, and I will stop here. There's so many things I would like to continue doing before I move on to the AR, but I think yeah, next week I'm probably gonna start working on the AR, and I might do some extra streams every now and then, maybe off, like camera off, just to make more chill at different hours, just to do some more documentation, because the documentation is extremely lackluster. There's a bunch of things to clean, but I don't want to only do that. I want to make progress. I think next week we're gonna start the lowering into AR. Okay, well, that's gonna be all for this evening. Yeah, this is too many. Not the best commit message. Good enough for this evening. Okay. Well, thank you again for tuning in. And I'll be back on Tuesday for probably the start of the IR work. See you then.